In this lesson, we will learn one-way analysis of variance. The ANOVA allows you to test for the difference between the means when you have 3 or more groups in your research study. Important note: in order to do one-way analysis of variance, you need to have installed the Data Analysis Tool Pack that was described in Lesson 4. If you did not install this, you need to do that now. We will work on practice example. Let's suppose that we are interested in comparing prices between 3 major supermarket chains. 1. Aeon Big, 2. Giant, and 3. Mydin. We have selected the 28 specific items listed in the table as the market basket of products to compare prices at these 3 supermarkets. This table summarizing the prices of the items in our market basket of products for these 3 supermarkets. Create an Excel spreadsheet for these data in this way. B1, Supermarket Price Comparison. A3, Item. B3, Aeon Big. C3, Giant. D3, Mydin. The task is to use Excel to perform a one-way ANOVA test. You are now ready to perform an ANOVA test on these data using the following steps. Click on Data, at top of screen. Click on Data Analysis, far right at top of screen. Click on ANOVA, Single Factor, scroll up to this formula and highlight it. Click OK. For input range, drag the value range from cell B3 to D31. For grouped by, choose columns. Put a check mark in Labels in first row. Output range, click on the button to its left, A36. Click OK. You should have generated the table given. All required data for ANOVA testing can be obtained here. As a check on your analysis, you should have the following in these cells. ANOVA allows you to test for the differences between means when you have 3 or more groups of data. This ANOVA test is called the F-test statistic, and is typically identified with the letter F. The formula for the F-test is this: F equals mean square between groups, MSB, divided by mean square within groups, MSW. To state the hypotheses, let's call Aeon Big as Group 1, Giant as Group 2, and Mydin as Group 3. The hypotheses would then be, H0, μ1 equals μ2 equals μ3. H1, μ1 not equal to μ2 not equal to μ3. The answer to this question is analogous to the decision rule used in this course for both the 1-group t-test and the 2-group d-test. You will recall that this rule in Lesson 2 and 3 was, if the absolute value of t is less than the critical t, we accept the null hypothesis. Note that Excel tells you the critical F value in cell G47 is 3.11. Our F value in cell E47 is 3.40. Therefore, our decision rule for the supermarket ANOVA test is this: since the value of F of 3.40 is greater than the critical F value of 3.11, we reject the null hypothesis and accept the research hypothesis. Therefore, our conclusion, in plain English, is, there is a significant difference between the population means of the 3 supermarket prices. I hope you have familiar with the basics of statistical function in Excel. And you now can use it to do data analysis and perform basic statistical procedures with Excel. Goodbye.